Hello and welcome to part 2 of DataKitchen's DataOps product training series. Part 1 of the series covered the IT admin role. Part 2, this part of the series, will cover the recipe developer role, and part 3 of the series will cover the operator role. One thing to note about our training session today is that much of what we'll cover is detailed in our documentation. And you can access that documentation by going to our homepage, which you'll see here, www.datakitchen.io. And if you click on the platform link, you'll be able to jump over to our documentation hosted on datakitchen.readme.io. And also accessible here, you can access our blog, the DataOps manifesto, and our Twitter account, where you can see recent updates around the phenomenon of DataOps, as well as what we've recently published, the DataOps Cookbook, which covers a lot of detailed DataOps best practices and strategies based on years of real-world experience. Much of what we'll cover today surrounds DataKitchen's UI tool. It's our web app accessible via web browser. But we also do have a command line interface, and the documentation is available here. And that's because users on teams that deliver data insights often have different levels of technical skill and prefer different tools. And we're helping to help those entire teams work to achieve DataOps best practices and the value derived therein. So we need to be able to support all of their workflows and use cases. So in this training session, we'll mostly cover the UI, but in some cases we'll jump over to look at the command line to show how they essentially have feature parity. And one other quick note about local tools we're using, because again, DataKitchen is an orchestrator of DataOps, and we are tool chain agnostic. So therefore we work with existing workflows and tools. So in some of the examples today, I'll be demoing some of my local tools that I prefer, and those include an IDE, and I prefer to use PyCharm, and a file transfer application, and I prefer Transmit 5. And I'm working on Mac OS, but the DataKitchen platform supports PC users as well. Okay, so I'll log into our UI. And you can see I land on a list of kitchens, and I'm logged in as my username, and if I click here, I can actually get a link to documentation, log out, and put in a support request. And you can also reach us anytime at support@datakitchen.io or at the shared Slack channel that you've been invited to. So we see our kitchen list here, and we ask, what are kitchens? Well, kitchens are workspaces where teams work to quickly deliver high-quality data insights. We covered these concepts in detail in the first part of our training session about the concepts or the properties of kitchens. So we'll quickly review those now, but I encourage you to review that training session for more detail. Kitchens are permissioned with a kitchen staff. Essentially, if you are a user who's not part of a staff, you cannot enter that kitchen. You cannot build and edit its recipes, you cannot run its orders, and you cannot manage the kitchen's workspace definition. And you'll see here with merging later, if I'm not part of the kitchen, I can merge from it, but I cannot merge to it. So in this case, this particular user would not be able to, as we'll see, deploy to master or deploy to production. Kitchens also have segregated infrastructure, and we work with, as we said, we're tool chain agnostic, so we work with many different tools. And the kitchens here are associated with segregated environments. So we have, in this case, a production environment associated with the master kitchen and a development environment associated with all of these kitchens here under dev. And for example, when we are running a recipe in a dev kitchen, like my kitchen, when I enter it, Eric Dev, We are running it against a dev instance of, say, that S3 bucket. And we'll see here that's because we have an S3 key that comes from the global secrets. And in this case, there's no AWS connections coming from the actual kitchen. These are global. Whereas in the production environment, in master, for example, if we ran that same recipe, we would run it against a production instance of an S3 bucket. It's totally segregated. Because we're actually calling the connection credentials from the kitchen level vault associated with the master kitchen, only accessible by the master kitchen, and only editable or manageable by those users who are part of this master kitchen's kitchen staff. So for example, most users will not have access to a master kitchen. And for some background, we use HashiCorp's Vault for our sensitive secret storage, which is encrypted, and those credentials are not surfaced within our platform. We jump back to our documentation here. We've talked about them being segregated infrastructure and secured via encrypted storage. They also support quality output. As mentioned, we think of recipes as assembly lines, and those assembly lines are in factories, which we call kitchens. So we have kitchens acting as factories or workspaces, and they contain assembly lines generating quality output that is tested in the form of recipes. And we'll touch on this a little bit more. Additionally, the contents of the kitchens themselves, the recipes, their code, configuration, and resource files are versioned. And that is because every kitchen is underpinned by a Git branch. So for example, if we just jump back here to our kitchens list and we look at the kitchens here, and then we also jump over to the underlying repository, we see that the list of branches is essentially equivalent to the list of kitchens. And because each kitchen is underpinned by a Git branch, those kitchens are hierarchical. And that means that you can essentially merge changes easily up and down the hierarchy change. And this is how we also support deployments, as we see here in the documentation. So generally, data kitchens help teams achieve DataOps best practices and therefore deliver high quality results very rapidly at scale. So now that we've taken a look at the concept of a data kitchen, from your perspective of a recipe developer, you don't need to worry about the higher level release environments like production. You need to only focus, and this is wonderful, on your own independent, controllable development workspace called your kitchen. And in my case, in this example, we'll look at mine, and that kitchen is Eric Dev, and we'll enter into it. So essentially, in my role as a recipe developer, I'm looking to, one, as I'm onboarding new pipelines into the DataKitchen platform, or essentially threading DataKitchen to work in parallel alongside them. I'm keeping my existing workflow with my local tools like we talked about earlier, my ID and my file transfer tool in this case. And I'm essentially using DataKitchen's orchestration framework to apply tests and to orchestrate the running of the pipelines. And again, collecting all of that centrally, the IP of those recipes in version control. So if we see here, I've entered into my kitchen and we have some high-level concepts. We have recipes, orders, ingredients, secrets, and history. So if we dive into secrets, for example, we can look again at our credentials that are available. So globally through dev, we have dev instances, and in this case, for some demos that we've done for this particular kitchen, we connect to some other infrastructure. And we also have a history through the versioning of the contents of the kitchen. And I can see all changes that have gone through, whatever the user is in the specific file, and I can actually dive in and see those changes. Here we have the recipes page, and the recipes are often considered data pipelines, but they're much more than that. They really are a collection of a series of steps, which we call nodes. And those steps can do data work, like moving files or performing queries that generate new tables in a database, for example. But they can also provision infrastructure, like create new clusters, or S3 buckets, or let's see, Redshift schemas, for example. So they really are essentially the assembly lines as described earlier that generate output. And again, they do it rapidly and at high quality. So if you look at the structure of a recipe, and we're going to look at this one demo today, we have an ability to dive in, and we can click on the configure link here. And we look at the underlying structure of the recipe. Again, it's a collection of nodes and steps, and we can jump over here and see what that looks like. These nodes are connected in a graph with edges, so here's a particularly complex example. And we can see that the graph really is just a reference of here are the node names and here are the edges, so really just defining the connections. And every recipe has one graph file. That graph file can have definitions of multiple graphs, but one graph file. Additionally, every recipe has one description file, and this essentially talks about the alerts and their destinations for each run of an order that's executed, a run of a recipe. And we'll talk a little bit more about that later. Recipes also all have a baseline variables file. And in this case, you can see the variables here. And additionally, if we think about variables, each recipe has a variable override structure. So the baseline recipe has a set of variables. There are also variations, as we'll talk about, that can essentially override the values that are defined for those variables in the variation file. You can also have variable values that are defined at the kitchen level as part of the kitchen workspace definition, and those override the values defined at both the variables and variations level. And so, for example, you'll see here there's a placeholder for SFTP connection because this is actually defined as part of the kitchen, and in that way this recipe code that again is under version control in this branch can easily be deployed up the stack to its parent kitchen and eventually into a parent kitchen way above in a totally separate release environment without issue, because the precise connection settings have been essentially extrapolated away up to the workspace level rather than as part of the recipe code itself. And each recipe also has a centralized area where there are resource files available to be called by that recipe. So we can see here is a SQL file with a simple query. And this content can actually be in line as part of our configuration, or it can be referenced here. It really is up to you, and oftentimes what's most easy when onboarding existing pipeline is to just drop in files like this to our pipelines and to essentially configure our orchestration framework around those existing files and pipelines to really be able to do DataOps at scale with them. So we can go back to our recipes list, and again we're looking at this prospect demo recipe. Again, we have this concept of variations. So variations are essentially slight variations of each recipe or flavors, to keep the kitchen and cooking analogy up, and they are saved configurations for that. And so what's the purpose of this? You might have a recipe, as we talked about before, that's quite large. So if we look here, and if you wanted to have a slight alteration on that, what you wouldn't want to do is create a whole nother variation, or excuse me, a whole nother recipe for that. So you have saved variations or saved configuration for that, which overrides the baseline value of the variables in kind of the baseline recipe value. So if we think about what are the ways that variations can be configured, so I'll just jump over here. You can have a baseline value here. So if we want to quickly look at this recipe, we can see it's got one node, or we can look at, the first variation. We could look at the second variation. We can see it's got one node. That's actually because what it's doing is pointing at different source data, so it's the same graph. This variation is, again, on demand. It actually cooks right when I run it, and its only difference is it has a different structured graph. And this one is actually, when I run it, it doesn't actually start cooking right away. It's waiting on a schedule. So in that way, I use variations essentially to override the baseline version of a recipe in three ways. One, to have a different graph. Two, to have a different schedule on which it runs. And we're going to talk more about schedule in the third part of this training series. And then also to the data that we actually point to run in a recipe. And that data might be based on subdirectory or based on a date, for example. So you might want to have call a path in S3, for example, based on the date, but not use today's present date, but use a date 20 years ago. Sometimes financial services clients like to do that for backfilling use cases, for example. So that's the concept of a variation. And I'm going to take this opportunity to just jump over now, change the context from our UI. Again, we're in a kitchen looking at recipe variations, just to jump over to our underlying file view. And I'll use the command line tool at the terminal here, so you can see my working directory. I'm essentially in a group kitchens directory. I'm in my Eric Dev Kitchen, and in this case I'm looking at the prospect demo recipe. So if I actually wanted, I'm looking at this one here. And then, so if I again I look at my prospect demo, I can see the underlying recipe. And this recipe actually has many nodes. These are the steps, and these steps have, for example, many source files which tell it what to do. That's the configuration, for example. It's oftentimes very short to accomplish big tasks. And you see our resources directory and then our 4 core files. So I can actually interact, and I have feature parity here at the command line versus the UI. So there's some cases where I want to use either or tool. And again, just to point back to overrides, you define base overrides and variables JSON. The variation has overrides that can override those values and variables, which can in turn be overridden by what's in kitchen JSON. And there are actually overrides you can submit when at the moment you're cooking an order run, and that overrides pretty much everything. And I'll just jump in and actually look back at this particular example. And let's look at our configure variations tab here, for example. So I can see my variations. There's no override set here for data, for example. And I'm just on an on-demand runtime setting. For these two variations, again, they have the same runtime setting, but they differ in their source data or their graph in these two cases. And this third one, the only real difference is that it has a different schedule. And here where we would actually look at overrides, so I can see the graph overrides. I'm just telling it to use alternative edges and nodes that are defined in our graph file, and here I'm actually overriding the source data value, which you would see here in the baseline definition here. And again, there's our graph file. So go back to our, and I'm just going to discard any changes I made, go back to our recipe list. And again, if we look at our graph and the way it's structured with nodes, again, they can be in series or in parallel, they can be very complex or simple. These are consisting of nodes, which are steps. And DataKitchen has several different node types, which we can jump over and take a look at. There's something called the do nothing node, and this is a node that really doesn't do data operations. it essentially serves as a placeholder in the graph, or really a convergence point, or a way to move a particular node up or down the graph, the graph levels, which can be beneficial in some cases. There's a data mapper node, which takes data from one place and puts data to another place and can do some transformations as part of that process. There are action nodes, which simply connects with one infrastructure tool in the tool chain. For example, it might connect with S3, for example. And I should actually say it might not connect just with one, but it will not move data from one to another. It might connect with multiple, but won't move them from one to another. But in most cases, you would connect with one piece of infrastructure with an action node. So 2 I/O connectors in a typical data mapper use case, data in, data out. 1 I/O connector with an action node, you're just making that connection and essentially communicating with it. Container nodes really support tools where we don't have default connectors. They also are really helpful for onboarding existing pipelines, because you can essentially take the existing steps, whether they be scripts or they be GUI tools that are part of an ETL process, and you can drop them in essentially as part of a DataKitchen recipe, and we talk with that recipe, or excuse me, that tool, to essentially execute its processing and pass parameters in and accept parameters from it that we use for the remaining orchestration of that pipeline. And these container nodes actually they're configured, and we'll look a little bit later, called Docker Hub to get specific images to build the container to process the contents that are put into them. So if we go back and look at our node types, you also have an ingredient node. So if we actually look back here at our variations, a recipe variation, we can take any given recipe variation and declare it as an ingredient. And what that means is that that ingredient or that recipe variation is available for reuse. So it can be called by 2 ways. It can be called as a substep when I create or delete kitchens, and this is often focused on that data infrastructure provisioning steps that the recipes can be written to achieve. So for example, in this account, if one creates a new kitchen, they have the option to also create a schema in Redshift. And that substep in its execution is actually driven by this create schema now recipe variation, which has been declared as an ingredient. So that's the first way that you can use ingredients, recipe variations, reuse recipe variations, excuse me, declared as ingredients. One is part of the kitchen creation and deletion process as substeps. And additionally, you can actually wrap these in a node themselves and have a whole recipe variation be executed as part of a node within another recipe variation by use of a container node, or excuse me, an ingredient node. And that is an advanced concept we won't speak too much about today, but again, there is that ingredient provider recipe and its variations that you can view in your account for more details. So just to jump in here, I can, for example, create a new recipe, and what I'll see here is I'm just given a baseline recipe, and I'll see here a new recipe, I'll edit its variation, and why don't I add a new node, and I'll just create an action node because I just want to connect with one tool chain in one tool in my tool chain. So I'll just call this connect to Redshift. Okay, so I've created a node, and you can see I can actually add an edge here as well. And even if I know nothing about version control, I'm actually adhering to DataOps best practices with version control, and each of the changes I've made are tracked in that underlying Git branch as we talked about. But if we think about these two nodes here that kind of start you off as a template, I can just remove these. So this is a way that I can quickly build graphs. And so now this is a one-node graph. We'll talk a little bit more about how to actually build out the contents of this graph, which I can get to by jumping into it. And we'll actually want to add an I/O connector to Redshift, which is a PostgreSQL data source. But we'll get there. Let's talk a little bit more about data sources and sinks. So we have a menu of what we support with these default connectors, and we can actually, based on use case, spin them up pretty quickly. And here's a menu of what's supported. And we actually also have detailed examples for each of these. So for example, we'll be working with cloud storage today, and there are some examples here, and BigQuery as well. So I can actually jump down in and look at, let's see here, for example, I want to bulk insert files, and this is some advanced Jinja templating, which we can talk a little bit more about later. Copy this content and drop it into my recipe file. So you can really get up and running quite quickly. But let's proceed forward, and I'll just add this. So I'll just call this a Redshift data source. And what I don't want to do is struggle with how do I get connected with this. And that's because it's great to work in a DataKitchen, because the IT admin role has essentially already set up everything that I needed. So I can look here for my Redshift credentials, and I want to use my username. I want to use the password that's associated with the Redshift database for this development environment. And again, I can go down here and find the host name and the port. And as well the database name. Okay, and now since I've made changes, I want to add Redshift data source. So by doing this update, we abstract away, again, the Git terminology in terms of making a commit, because we don't want to force users to learn all the ins and outs of Git and version control. We just want them to follow version control best practices. And if we actually go look at our history, we can see the data source that I just made and the changes that I applied. So if we actually go back to that file, we can see that what I've done is I've used parameters here, and again, we've done that because we want to make this recipe portable across kitchens and really environments, so that when I run this in the DevKitchen, it knows to connect to the Redshift defined by the DevKitchen workspace, and when I run it in production or master, it connects to the production instance of the database. And I can make sure I'm kind of connecting properly by compiling this file. And I'm actually able to see all of the values except for those that I've put into the vault, because again, we don't want to surface those. So this is how I would connect to a Redshift data source. And again, we have connections, default I/O connectors to many tools. But we actually support a much larger menu of tools. And if you remember back, we talked about container nodes. By using containers, we can basically integrate with essentially any tool with a number of different approaches, which are reviewed in some of our architecture training videos. And in addition to this, the container nodes, as described, also allow you to take these existing pipelines and quickly wrap DataKitchen around their orchestration. So I can take existing Python or shell scripts, for example, and just drop them in to be run in a container, and I'm good to go. I don't have to refactor the entire existing pipeline. I can get it running with DataKitchen, and then as I run it over time, add more tests to guarantee more quality, have all that be under version control, and in that way I can iterate more quickly. So if we just jump back to look at a particular graph, we see here this graph has one node, one step. And if we dive in, this has a number of files. We kind of saw the file structure that we looked at the command line. And I don't have this locally because this is a new kitchen that I have not pulled a copy of locally yet. But if I look at the data source, there are actually keys, a number of keys that run. Now, I haven't created any of these keys yet, but keys are the substeps that run within a node. And in addition to keys, there are tests. And the tests are what really guarantee the quality of your output, because not only do they tell you, yes, this particular key, this substep within any given step within potentially a graph that has potentially hundreds of nodes, this is the result of a test failure or not, but it actually allows you to, in some cases, if you'd like, stop that assembly line of the recipe right in place and then quickly be able to adjudicate that failure and restart in place the assembly line so you can quickly move forward and really catch any issues before they ever end up in your client's hands. So we've talked a little bit about recipes and actually quite a bit. So when we actually run a recipe variation in a kitchen, so again we run a recipe variation in a kitchen, we generate an order. So by cooking a recipe variation in a kitchen, we generate an order. And again, orders can be scheduled at many different times, and we'll cover that next time. And there are concepts between orders and order runs. So again, if I want to look at the orders here and the order runs in a kitchen, I have to be in that kitchen. They are distinct across kitchens, just like the underlying copies of the recipes. And every order has at least one order run. An order may have multiple order runs if that order is essentially scheduled to repeat. For orders that run via DataKitchen, we provide useful information regarding a couple of different things. One that we talked about, tests. We actually can look at a longitudinal view of tests, and here's an example in your account. If I just zoom out, I can actually see over time tests, and this helps me understand trends and actually narrow in on root cause analysis, which is really helpful to an operator role who might not have actually built this recipe. And then if I go back to my orders page, I also have timing information, and this is actually helpful upstream to the recipe developer, but also to the IT and admin role to really understand the timing information between separate order runs of a recipe, and then in that order run the actual separate steps. So here there are actually many different nodes, and you can see the actual different keys within those nodes, so that timing information can be very helpful. So that's the order summary, and that's for a summary for a specific recipe variation combination in a kitchen. We can actually dive into any given order run and look at its order run ID. And that is again unique to every order run. And what we see here, I can see this order run was successful. I can see some summary information. There are actually test results for this actual order run, and there what's really helpful are unified logs of every tool that's used. So in this case there's SFTP, Google Cloud Storage, BigQuery, and logs from DataKitchen, and they're unified here. I can actually go down and get much more detail, and these are searchable. So I can search for a DK data test, for example, and I can see all of these tests around in this order. These are exportable, as is your recipe graph. And you actually get alerts when these run, and you can be very selective and